In this video, we're going to be looking at topic 4D, the alkenes, and this is part of the IGCSE chemistry course from Edexcel, and we're going to be looking at the double content. So our learning outcomes are to cover the functional group and general formula for the alkenes. We're also going to look at why we classify them as unsaturated hydrocarbons, looking at the particular reactions with bromine, and how we can use bromine water to distinguish between an alkane and an alkene. So alkanes are a homologous series of hydrocarbons, and remember, a homologous series is another word for a family, meaning that they have the same general formula, they show trends in their physical properties, and they are also sharing the same chemical properties. And they are hydrocarbons, meaning they are hydrogen and carbon only, and they contain this functional group of a carbon-to-carbon double bond. This is what makes them different from the alkanes, and because they contain this double bond, we call them unsaturated. So unsaturated simply means there is the presence of a double bond. This is the opposite to the alkanes, which we've said are saturated molecules because they contain only single bonds between their carbons. So the alkenes are known as unsaturated. So the alkanes have the general formula CnH2n, and as with the alkanes, we strongly recommend that you memorise this formula because it is a very common exam question. And you can then use this to determine the number of hydrogens in any compound if you know the number of carbons. So for example, if N is equal to 20 carbons, then we know that H is going to be equal to twice that number, which is 40, and we can then say that an alkene with 20 carbons is going to have a formula of C20H40. Now, when it comes to the names, formula, and structures, you only need to know the first three members of the alkenes, up to having 4 carbons. And this is the same as what you needed to know for the alkanes. So we're going to be looking at the name, the molecular formula, structural and displayed formula for each of the alkenes. And if you remember when we discussed the alkanes, we said that you should think of the name as a first name and a family name. And the alkanes all ended with ANE. The alkenes are very much the same, however, they will all end in ENE. And this will be the family name or the surname. And the first part of the name will tell you how many carbons are present. Now, the first member of the alkenes cannot contain 1 carbon because it has to have the functional group C double bond C. So therefore, your first member is actually 2 carbons, and we call this ethene, with ene being the family name to tell us it's part of the alkenes, and eth meaning 2. So to make it nice and simple, we're going to jump over to the displayed formula and then we will work our way back. So our displayed formula is going to have 2 carbons double bonded together, and then we're going to fill in the hydrogens, making sure that each carbon has 4 bonds. So where this is slightly different from the alkanes is that the carbons next to the double bonds should only have maximum of 2 hydrogens because they already have 2 bonds to the other carbon. When we then show this in the structural formula, we have to show the presence of the double bond. So we would write CH2 and then show the double bond and CH2 again. And then our molecular formula is simply counting. I have 2 carbons and 4 hydrogens. And we know that because our general formula, remember, is CnH2n. The second member of the alkenes is going to contain 3 carbons, and we call this propene, prop meaning 3. So I draw my 3 carbons, and then it doesn't matter where I put the double bond. In this case, I'm going to put the double bond between the first 2 carbons, and then the second set of carbons will contain a single bond. Your alkenes should only have 1 double bond. And again, we fill in the hydrogens, making sure that every carbon has no more than 4 bonds. So what you'll see is we have this sort of empty space underneath the carbon-to-carbon double bond, and that's okay because each carbon has 4 bonds, and that's the most important thing. We then look at the structural, and we have CH2, a double bond, a CH on its own, and then the CH3. Remember, the structural formula is breaking it down into these small chunks of carbons and how many hydrogens there are. And then for the molecular, we're going to count. We have C3H6. And again, that fits in with our general formula. Then we move on to the third member, which is 4 carbons. So this is butene. Now, butene is where we start to see a slight difference with the alkenes, and we'll talk a little bit more about that in just a few minutes. We're just going to stick with our 4 carbons in a row, and we're going to put our double bond between carbon number 1 and carbon number 2. Now, that can change, but as I said, we'll talk about that in just a few minutes. All the rest are going to be our single bonds. And then we put in all of our hydrogens, making sure that every carbon has no more than 4 bonds. And we write out our structural formula, which is CH2. We show our double bond. We have CH, a CH2, and a CH3. And then we count up our carbons and hydrogens, and that gives us C4H8, again fitting in with our general formula of CnH2n. So you can see here that we've got the same table, just slightly neater, where we have our first 3 members with our molecular, structural, and displayed formula. Notice that they also show the empirical formula, so that is the simplest whole number ratio. And in this case, the empirical formula is simply CH2, because we're always going to be able to divide down to get the simplest whole number as a 1:2 ratio between our carbons and our hydrogens. Now, as with the alkanes, we can also see isomers of the alkenes. So remember, isomers is when we have the same molecular formula, but a different structural formula. And the most common isomers that we get for the alkenes is by changing the position of the double bond. And we can see this in a molecule that has the molecular formula C4H8. We can actually have 3 different isomers for this molecule. So if we take our 3 structures and we try to figure out what they would be, we put 4 carbons in a row for my C4, and I can put my double bond between carbon number 1 and carbon 2. And when I add in my hydrogens and my remaining single bonds, we can see that that is C4H8. And we call this molecule but1ene. And the 1 in the centre tells us the position of the double bond. It tells us it's between carbon number 1 and carbon number 2. I can then, however, have my 4 carbons, and I can put my double bond between carbons number 2 and 3. And then when I add in the rest of my single bonds and my hydrogens, making sure to have no more than 4 bonds to each carbon, we can see this is also C4H8, but it is completely different from the previous structure. So we have to call this something different. And this is but2ene. And the 2 tells us that the double bond is between carbon number 2 and carbon number 3. Now, similar to the alkanes, not only can we change the position of the double bond, we can also add branches or side chains. So what I can do is take these 4 carbons in a row and make one of them into a side chain. So I have 3 carbons, and in the center, I have 1 carbon connected as a branch. Now, the double bond, it doesn't matter whether it goes between the first 2 or the second 2 carbons, because it would be named the same. So we're going to put it between the first 2, and then I have my single bond. And then I add in my hydrogens, making sure that each only has 4 bonds. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Again, C4H8, but we know that this is something different because it looks completely different. And we call this 2-methyl propene. So the propene tells us that the main chain is 3 carbons with a double bond, and on the second carbon we have a methyl group. Now each of these are isomers, as they all have the formula C4H8. I would strongly suggest that you practice drawing out isomers. You won't be asked any more than, I would say, 6 carbons. So if you can draw out isomers for C4H8, C5H10, and potentially C6H12, you're going to make your life a lot easier when it comes to the exam. Of course, you can ask your teacher if you are struggling, but remember, you can always change the position of the double bond, or you can add in branches. And you should be able to draw and hopefully name some of these as well. If you're not too sure with the naming, you might want to check out the video that we have on naming hydrocarbons on this YouTube channel. Now, as they are a homologous series, the alkenes are going to show trends in their physical properties, and the trends are going to be the same as the alkanes. They are gases up to C4H8, they are liquids then up to C16H32, and then they are solids after this. So what we're seeing is we increase the number of carbons, we increase the boiling point. And that is due to the intermolecular forces becoming stronger between the molecules, meaning they require more energy to be broken. So we see that same trend. Now, what is the big difference is the chemical properties. The chemical reactions of the alkenes are remarkably different to the alkanes, and it is because of the presence of this double bond. This double bond actually makes the alkenes much more reactive than the alkanes. And there are a few reactions that you have to know. So the first one is combustion. We always want to look at the combustion of hydrocarbons, and whether it's an alkane or an alkene, it does not matter when it undergoes combustion. We are going to get the same products being formed, whether it is complete or incomplete. So if we have the complete combustion of ethene, for example, that's C2H4, which is a gas, and when we're combusting it, we react it with oxygen, and it is always going to make carbon dioxide and water. If it was incomplete combustion, remember that's going to make carbon monoxide, which is that poisonous gas that we don't want to be breathing in. But if we have complete combustion, we get the CO2 and the H2O, and of course we should be balancing. So when you balance any hydrocarbon combustion equation, you start with the carbons. So I have 2 on the left, I need 2 on the right. I have 4 hydrogens in my reactants. My products, I only have 2, so I need to put a coefficient of 2 in front of the waters. Now I add up my number of oxygens. Well, I have 4 coming from the CO2, and I have 2 coming from the water, which gives me 6, meaning I need a coefficient of 3. And that's the balanced chemical equation for the complete combustion of ethene. Now, alkenes are very rarely burned. If we're going to be burning any hydrocarbons, it tends to be the alkanes or some other hydrocarbons that we don't need to know about at this point. The alkenes are much more useful in other chemical reactions, so we use them more for that. And the most common ones are addition reactions, which we're going to look at next, or polymerization reactions, which you'll cover in topic 4H, which is synthetic polymers. So we're going to look at the addition reaction. Now, alkanes underwent substitution reactions. Alkenes undergo addition. And because of this double bond, we know that the alkenes are much more reactive. And an addition reaction happens when this carbon-to-carbon double bond breaks to become a single bond, and then we add in other atoms to those carbons. So we are adding atoms to the molecule. This is why we call them addition reactions. So we break the double bond to a single bond, and then because each carbon has to have 4 bonds, we then add in some extra atoms. Because when the double bond breaks, it means that that electron on the carbon atom is going to become unpaired, and we don't want an unpaired electron, so we want it to form bonds with something else. So alkanes will undergo addition reactions, in particular with the halogens. Now we learned back when we looked at the alkanes that the alkanes undergo substitution reactions with the halogens. And we discussed that when this reaction happens, we require UV light. Now, the difference with the alkenes is the alkenes are so reactive that they will react with the halogens without the need for heat, light, or a catalyst. They will simply react by being in the presence of each other. And the product that we formed is a colourless bromoalkane. So we go from having an alkene with a double bond to having a bromoalkane that is completely saturated. And we can write out a chemical equation, a displayed formula equation, and a word equation to show this. So let's look at the reaction with ethene. So ethene, remember, is C2H4. So we have our structure like that, and it is a gas. And we're going to react it with bromine. And when we react it with bromine, remember bromine is diatomic, so it is 2 bromine atoms joined together, and that is Br2, and we use an aqueous form of it, known usually as bromine water. And this will then react. So what happens is this double bond here breaks and converts into a single bond. Now we still have our hydrogens attached. That does not change. But now what happens is each carbon, you can see here, is missing another bond. And what it does is it actually bonds to the 2 bromines. So we have 1 bromine on the first carbon and 1 bromine on the second carbon. And so this then becomes CH2Br, CH2Br. And this is a liquid, and we call this 1,2-dibromoalkane. Or if we want to be even more specific, it's 1,2-dibromoethane. And this tells us that the ethane tells us we have 2 carbons, and the 1,2-dibromo tells us I have 2 bromine atoms, and one is connected to carbon number 1 and one is connected to carbon number 2. So that is the addition reaction. We have this carbon to carbon double bond breaking and forming a single bond, and then the 2 bromines adding on to the product to give us a saturated molecule. We're going from unsaturated to saturated. Now this change in saturation is actually then used to apply as a chemical test. So alkanes and alkenes are both colourless liquids, and they look exactly the same. So if we have 2 bottles of the colourless liquids and we don't know which one is which, we would need to do a chemical test in order to separate them. Now, you've looked at chemical tests back in topic 2H when you were looking at cations and anions and testing for gases. This is just the same. The only difference is this time it's an organic substance. And we can take advantage of this reaction with bromine water with the carbon-to-carbon double bond to test for unsaturation. So what's important for you to remember is this. What we use is bromine water. And we should always be explaining what reagent we're using and what we see. So what is our observation? So the alkenes, when we add in the bromine water, are going to react because they are unsaturated. So the alkene, being unsaturated, is going to break the double bond and allow the bromine water to add across in an addition reaction, like we've just seen. Now the alkanes, because they do not have this double bond, they do not react. So we don't see any reaction here. So what happens is when the bromine water, which is this orange colour, is added into the alkene, it will decolorize, meaning it goes from orange to colourless. This change is not seen with an alkane. So if we have our two colourless liquids and one of them decolorizes the bromine water and one of them does not, then we have an alkene which decolorizes and an alkane which does not. So we get something that looks like this. So we have our bromine water, which is orange, adding into the alkene, turning colourless, adding into the alkane, there is no change. So this is known as testing for unsaturation, and it allows us to distinguish between alkanes and alkenes. So now let's take what we know and what we've learned in this topic and apply it to some past paper questions. So the table shows the displayed formula of 3 unsaturated hydrocarbons. Question A, explain the meaning of the term hydrocarbon. I've said several times now that this comes up time and time again in exam papers. So we have molecules made of carbon and hydrogen. And remember that keyword, only. That's where you get that second mark from. And then for part B, explain the meaning of the term unsaturated. Well, when we have unsaturated, it means that we have carbon to carbon double bonds are present in the molecule. So remember, saturated means it's only single bonds. Unsaturated means we have at least one carbon to carbon double bond. Okay, and you have to be specific that it's between the two carbons. Don't mention any hydrogens when it comes to talking about unsaturation. So compounds A, B, and C all belong to the same homologous series, and one characteristic of a homologous series is that they have the same general formula. So the first part is, what is the name of this? So if we go back, we can see that they are all containing double bonds, and we've been talking about it this entire video. This is the alkenes. And then what is the general formula? Well, it's CnH2n. And be careful to make sure that your N and your 2N are subscript. They should not be the same size as your carbon and your hydrogen. They are subscripts. And then state 2 other characteristics of compounds in a homologous series. So the first one that we were given is that they have the same general formula. There are 4 possible answers here. So we can say that they have the same chemical properties. They show a trend in physical properties. So remember, that's your boiling point or melting point. They also have the same functional group. And lastly, the members differ by CH2. So each time we move through the members of a homologous series, we're adding in 1 carbon and 2 hydrogens. Any 2 of them would get you the 2 marks. Okay. We're going to focus now on compound C, and we can see the structure here, and we want to say, what is the name of this? Well, we have 4 carbons in a row, and our double bond is between carbon number 1 and carbon number 2. So this molecule is but-1-ene. You have to be very specific and say that it is between carbon 1 and carbon 2, because remember, we can have isomers here. The molecular formula is just simply counting. I have 4 carbons and 8 hydrogens, so it is C4H8. Now, speaking of isomers, what is the meaning of the term? And this is for 2 marks. So we want to say that they have the same molecular formula, but different structural or displayed formulas. So they can have the same molecular, C4H8 for example, but they have different structures. And then we want to give any isomer of compound C. Well, the most common isomer, as we've said, is just to simply move the double bond. So let's have our 4 carbons, and we'll put our double bond between carbons 2 and 3, fill the rest with single bonds, and then of course add in all my hydrogens, making sure I have no more than 4 bonds. It doesn't ask us to name it, but we could and say that this is but-2-ene. Now we want to complete the chemical equation for the reaction between compound A and bromine water. So this was the C2H4 plus the Br2. So all we're doing here is we're breaking that double bond, and then we're adding in the Br2. So because it's a chemical equation, we want just the molecular formula. So we would have 2 carbons, 4 hydrogens, and then the 2 bromines are added. So if you have an addition reaction like this, you simply just add the 2 formulas together, and that gives you the formula of your product. Now when heptene is added to bromine water and the mixture is shaken, now it doesn't matter that we've not looked at heptene being 7 carbons in an alkene. We know that it's an alkene because it ends in ene, and all the alkenes are going to react in the same way. So when they are shaken, a reaction occurs. We want to state the type of reaction and give the colour of the bromine water before and after. So because it is an alkene reacting with bromine water, this is an addition reaction. The colour of the bromine water at the start is orange. You may also say yellow or brown. You can't say red. Okay, red is not an accepted answer. It's either orange, yellow, or brown. And the colour after is colourless. Remember, it is not clear, it is colourless. And then lastly, explain in terms of the bonds present why heptane is described as saturated and heptene is described as unsaturated. So this is simply asking, what is the difference between saturated and unsaturated? So saturated means it contains all single bonds, and we have to be specific here and state that that means between the carbons. Of course, the carbon to hydrogen bonds are single bonds, but it is all single bonds between the carbons. And unsaturated means it contains carbon to carbon double bonds. Okay? Or you can even use the term multiple bonds, meaning we could have double or even triple bonds. So we're stating single bonds only for saturated, double bonds for unsaturated. Now there you can see the mark scheme to all those questions if you were working through them as well. Now that's everything for topic 4D, the alkenes, for the double content. The recommendations would be to make sure that you can draw out the chemical structure, the molecular formula, the displayed structure for each of the alkenes that we've looked at. Also being able to write out the formula and equations for the addition reactions, and try naming some of these compounds as well. If you do have any questions, please feel free to leave a comment below, and we hope to see you back soon.